need a lot of time to write this stuff down. We got a lot of vocabulary, a lot of definitions and examples to go with this, and we're talking about statements. So a conditional statement is a statement that can be written using the terms if and then. So a hypothesis is the part of the conditional statement that follows if. We've got it recognized as the letter P, which we're going to use throughout this chapter. P is going to represent the first part of the hypothesis of the conditional statement. Conclusion is the part that follows the word then, and we're going to call that Q. So for example, if I take this statement, if I am 16, then I can drive a car, I am 16 is my hypothesis P, and I can drive a car is my conclusion Q. Now, since we can write them in sentences, we can also, and we've given them letters P and Q, we can also write them using symbols. As mathematicians, we didn't study English for a reason. We don't really want to write down everything all the time, so being able to go back and forth between symbolic notation and regular writing notation is going to be a good benefit for us. So we're going to talk about symbolic notation. This guy right here, the arrow between P and Q, is going to indicate that we're saying if P then Q, or P implies Q. So for the next example, we're going to state the hypothesis and the conclusion. The first example is if an animal is a robin and the animal is a bird. Take a second on your own and see if you can write down what the hypothesis is and what the conclusion is. Okay, so hopefully you wrote down the hypothesis. It's going to be the part right after the word if. So here's if. An animal is a robin is going to be that hypothesis. So I'm going to write down an animal is a robin. Okay. My conclusion is the part after then. So here's the word then. My conclusion is the animal is a bird. So we're going to write that down. The animal is a bird. So hopefully you guys got that right. And we're going to go ahead and move on to do a couple more examples. Okay, so we're going to write a conditional statement. And remember, conditional statement means we've got the word if, we've got the word then. These statements right here don't have those two things, so we've got to transform them. Our first process is going to be to figure out, well, what is the hypothesis in this problem? What are we predicting is going to happen? What are we basing this on? So example one, which is, by the way, a very true statement, cool girls love math, which is what makes Miss White and I so cool. We're going to come up with what the hypothesis is. And I'm saying the hypothesis is what we come up with first. So, cool girls. There are cool girls. And you can add kind of this part right here. That should be there. You can kind of change it around. If there is a cool girl, there are cool girls. A person is a cool girl, whatever you want to add there. So that's my hypothesis. My conclusion is going to be they love math. And you want this to match whatever your tense is or your grouping is. So if you're talking about one cool girl in the hypothesis, you want to talk about one cool girl in the conclusion. So how do we put this all together? My statement is going to read if, because we got to start with that, there are cool girls. Then I'm going to put my conclusion. They love math. Okay, so trying this on your own for the next one, I've given you the statement that even numbers are divisible by 2. See if you can come up with the hypothesis, what the conclusion is, and see if you can come up with a conditional. Now, yours might not match exactly the way mine is, but we should still have even numbers in the same spot and divisible by 2 in the same spot. So, even numbers are divisible by 2. I'm saying my hypothesis is that it is an even number. Okay, so my conclusion is going to be that it is divisible by 2. So what's going to be my conditional statement? I'm going to say if it is an even number, then it is divisible by 2. So if moving on. All right, conditional statements can be rearranged to give different truth values and come up with different situations. And sometimes we can make implications from those, again, using inductive reasoning and what we're going to talk about later, deductive reasoning. The types of statements we can rearrange these in is to converse, inverse, and contrapositive. So go ahead and write those down, make yourself a little chart just like mine, and we're going to do what it is in words, and we're going to say what it is in symbolic notation. Okay, so once you're ready, go ahead and unpause and let's go. In words, the conditional statement is what we've been talking about. If P, then Q. Symbolic notation is just going to be P, the arrow, and then Q. So the converse. I always think of Converse sneakers and Michael Jackson wearing them. I don't know why, but Converse and Michael Jackson, for me, he's going to do the moonwalk, so he's going to go backwards. Yeah, I'm doing the moonwalk really well right now. I know you saw that, right? So what it does is it takes the P and the Q and switches places with them. It flip-flops them. So we haven't changed anything except the order that everything's showing up in. Your notation is going to be that Q implies P. So again, Converse, moonwalk, Michael Jackson. You got it? All right, cool. Inverse. All right. I do like English, and the prefix in means not. Okay? So what we're going to do is we're going to keep this in order. So I'm using the in as a double memory device for me. In order is the conditional, but not the conditional. So we're going to say if not P, then not Q. And in symbols, we're going to use this squiggly to represent that we're not what we started with. Okay, the contrapositive is the longest word up here, so it does the most. So it's going to do the same things that we did with the converse and the inverse. It's going to switch the order and make it not. So if not Q, then not P. And here's your symbolic notation. And again, note that if I talk about this, the word negation, I'm referring to this symbol right here. I'm changing it from positive to negative or negative to positive. All right, so let's go ahead and see if we can do this real quick. We're going to write a conditional converse, inverse, and contrapositive of each example. Okay? So go ahead and pause it, see if you can write yours on your own. Cool girls love math. We already came up with the conditional. If I am a cool girl, then I love math. My converse for that is literally going to take I am a cool girl, oops, and switch it with I love math. So these guys are going to trade places. So if I love math, then I am a cool girl. And again, you don't have to use the word I in front of it. You can say if someone is, if a person is, so on and so forth. Now, like we talked about, the inverse is going to stay in order, but make it negative. So we're going to go back to the conditional, and we're going to write this again. If, but instead of being a cool girl like I was up there, I am not a cool girl. Then, and instead of loving math, I'm going to say I don't love math. And last but not least, we're going to do the contrapositive, which we said does the most. So I'm going to kind of combine the converse and the inverse, or take the inverse, or excuse me, the converse of the inverse. It's kind of confusing. Anywho, if, so I don't want to say I'm not a cool girl yet, I don't want to repeat myself, but if I don't love math, then I am not a cool girl. Okay, so hopefully you got all of those. Try this one on your own. Go ahead and pause it, see if you can figure it out. I've already given you the conditional statement, so all you have to do is come up with the converse, inverse, and contrapositive. Okay, so hopefully you've had enough time to finish that. You should have come up with something similar to this. Make sure that you've got the hypothesis, 4 sides at first, then it's a rectangle. Make sure you start there. Make sure everything's in the right order. You've got knots when you're supposed to, and you don't have them when you're not supposed to. All right, so what is a compound statement? Like compound words, compound sentences, anything like that, is you're taking more than one thing and stringing it together. So our definition for a compound statement is that it combines two or more statements. There are two ways that we can do this, either with a conjunction or disjunction. Con, with, dis, not with. Okay? So your conjunction and your, let me move it over there. Conjunction is the one that connects two or more statements with the word and. Okay? The symbol is this guy right here. It's like an A, capital A, but without the bar in between. So for example, we've got S and J. Okay? So this says S and J. And to talk about true or false, this statement will only be true if both S is true and J is true. Okay? In a disjunction, we're using the word or. So it connects two or more statements with the word or, and it's an upside down or regular V. Okay? So this guy says S or J. Meaning it can happen and it can be true if S is true or if J is true. They don't both have to be true, but one of them does in order for this to remain a true statement. All right, let's do an example to make this kind of make a little bit more sense. I've got three statements going on up here, S, J, and T. S says we will go to the movies, J will go to the mall, T will go to the beach. What I want you to do is interpret each of these. S, I'm not going to read it out loud because I want you to take a second to figure it out, and interpret this and see if you can come up with a sentence for each one of those scenarios. Okay, pause it and do that now. We'll go over the answer in just a second. All right, this is the answer that we came up with. So if S and J, then we're going to go to the movies and we're going to go to the mall. Okay, this one over here, S or, but then I want to make sure that I'm going to do J and T together. So we will go to the movies or we'll go to both the mall and the beach. Is going to come talk to you guys about 2.3.
All right, so last section for today. And we're going to go back to our P's and our Q's, but now we're going to be talking about biconditional statements. And up top here we have exactly what a biconditional statement is. It combines a true conditional, so you have to read through the conditional statement and say, is this a true statement, with a true converse. So if you flipped it around and the sentence is still a true statement, then you are able to write the biconditional. Meaning, P implies Q is true, and then you can go backwards, Q implies P, so therefore the double arrow represents the biconditional, okay? So you are only allowed to do that if both these are true statements, okay? Now, we aren't using the words if and then anymore. If and then go with the conditional statements, converse, inverse, and contrapositive. If we're talking about a biconditional, the wording we use is the words if and only if. All right, so we're going to look at this first example where it says, write the following as a biconditional statement. The sentence states, if two angles are supplementary, then they add up to be 180, which is a true statement, so that's our conditional. And then if I flip it and just look and read, all right, if they add up to be 180, then the two angles are supplementary. So I can definitely write a biconditional with that. The easiest way to tell you guys to write a biconditional is the if and thens go away. We don't need this anymore because we're doing if and only if. Where the word then is where you insert the words if and only if. So our statement will start out with two angles are supplementary. I might run out of room here. I'm going to write it sideways. If and only if they add to be 180. So that is what a biconditional looks like. Okay, remove the if and then insert if and only if. So go ahead and read through. It says write each of the following statements as a biconditional statement. So we've started out with not a conditional statement. So just like you practiced with Ms. Hurst, go ahead and write a conditional statement. Take the sentence triangles triangles are three-sided polygons. Write the conditional, the converse, and then what I just taught you, write the biconditional. So go ahead and pause, and then we'll check the answers. All right, so hopefully you were able to write the conditional. Let me extend the page here. Okay. Okay, so conditional, remember the order stays the same. So if it is a triangle, then it has three sides. You could have written if a figure is a triangle, just as long as you have the triangle as your hypothesis part and three sides is your conclusion part. Now the converse, remember we're just flipping it, so if it has three sides, then it is a triangle. Because both of these are true statements, we're going to go ahead and write the biconditional. So it is a triangle if and only if it has three sides. That's that part here where the then used to be, and we don't take the if there. So that is a biconditional statement. Last example of the day gives you a biconditional statement, but it wants you to write the two conditional statements from it. So when they ask you that, that means can you split it up and go backwards and write the conditional and the converse. So a triangle is a right triangle if and only if a squared plus b squared equals c squared. Go ahead and pause and see if you can write the conditional and the converse from this biconditional. All right, so let's take a look, check over, see if you did it correctly. So first one, conditional. If it a triangle, that doesn't make sense. If it is a triangle, oh, I'm sorry, I read it wrong. It does make sense. If it a triangle,
Take out the word a.
yeah. Okay, there we go. Thanks, Ms. Hurst. If a triangle is a right triangle, then a squared plus b squared equals c squared. Whew, that threw me off. All right, and then we're going to flip it. So if a squared plus b squared equals c squared, then a triangle is a right triangle. So that works out. There's our conditional and our converse from our biconditional.
Now remember that Miss White told you if and only if replace the word then. So you can go backwards and put then back where if and only if is and put your if in front.
There you go. Little handy dandy tip. Okay? All right, so we are done with sections 2.1 to 2.3. Now tomorrow in class we're going to do an activity. It is a graded assignment. So what we're asking you guys to do is bring in an old magazine. It will help you. You will be working in groups, but if everybody has a magazine, it'll make it much easier for you tomorrow. So see you in class tomorrow.